to look at law of logarithm. We have different law of logarithm. We have the addition law, the subtraction law, the power law. Power of the base, the logarithm of its own base, logarithm of 1, and reciprocal law. The addition law says that log a raised to power x plus log a raised to power y is equal to log a x y. That in addition law, we are doing what? Times. We have to times the power. Then in subtraction law, you do what? You divide the power. Then the power law, you can see we have log a raised to power xn. Whatever power you have here, you bring it at the back, which is n log a raised to power x. So we are going to solve for this now. If you look at this example, we are going to look at this is an example of the addition law. It says we should look for log 10 raised to power 4 plus log 10 raised to power 25. So the first thing I'm going to do, I'm going to bring out my log 4 raised to power 20, log 10 raised to power 4 plus log 10 raised to power 25. Then the addition law says that we're going to do what? Times the what? Power. So I'm going to bring my log 10. We have what? The power we have is 4 times what? 25. Addition law means you are timesing the what? Power. So I'm going to times this now. So we have log 10. 4 times 25 will give us what? 100. So once you are getting to this stage, the next thing you are going to put this 100, the power, into an index form that the base must be the same with what you have here. So let's go. Log 10. Putting 100 in index form, that your base must be the same with what you have here is going to be what? 10 raised to power 2 to give us what? 100, which is what? 10 times 10. So I'm going to write what? 10 raised to power 2. When you are putting it in index form, you must make sure that whatever you have here must be the same, correspond with what you have under. So now the same thing applies there. So I'm going to say log 10, bring these two at the back. So you can see this 2 now is an example of what? We are making use of what? The power law. Well, when the power, whatever you have here as your power comes to the back. So these 2 now we have here is going to come to the back. So I'm going to bring these 2 at the back of our log. Then put your 10 raised to power 10. So the next thing we are going to do now, I'm going to bring out this my 2. Log 10 raised to power 10 is an example of what? Logarithm of its own, they have the same what? Base. This is an example of what we have here. Look at it here. Logarithm of its own base. Where the two base, the power and base are the same. And when the power and base are the same, it's equal to what? 1. So you can see we have what? Log 10 raised to power 10. That shows that log 10 raised to power 10 is what? Equals to what? 1. So bring this my 2 and put my times 1. This log 10 raised to power 10 is the same thing as what? 1. I'm going to say where log 10 raised to power 10 is equals to what? 1. So 2 times 1 will give us what? 2. So this is our answer. Then we'll go to example 2. Example 2 says take the example 2, log 428 minus log 414. Remember, this is an example of what? The subtraction law. Where you do what? Where you divide the what? Power. So what we are going to do here is this. I'm going to say log 428 divided by what? 14. So let's go. We have what? Log 428 divided by 14 will give us what? 2. So we have us what? 1, 2 ways to divide 5 will give us what? 2. So what we have here is what? Log 1 all over 2. So our answer here is what? 1 all over 2.